So I will show you how to solve question 2, assignment 2A, question A. Okay. So firstly, kita copy paste code dari buku. Okay, just copy. Masya Allah, macam ni buat jadi lah. Okay. So this is your function to calculate the ODE equation. And then you create another function and copy the second code here. This is your second code. Okay, so after copying the code, then you check for the parameters whether it's correct or not. Okay, so the initial value, it's this one. This line here is your initial values. Okay, so it seems that everything is correct. Then you check for the time range. So until 0.002 second. So until 0.02 second. So this is the time span. So you can write time span outside, okay? It's the same. And then this part here, ice steam. So ice steam here. says that from 0.001 until 0.002 second, I step equals negative 60,000. So here T bigger than T on, so T on is 0.001 until T less than T on plus T dur. So T dur is 0.01, 0.001. So if you add together, then it's correct, okay, 0.002. So IS here should be negative 60,000. So here it's positive, so you just put negative here. And then 0 for other times. Okay, should be okay dah. And then you save. Okay, after saving that, then you can run. Macam salah je. Okay. Okay, so yang ni jadi positif lah. Kalau negatif tu salah. Okay, so tukar, okay. So this one change to positive 60,000, okay. Okay, so after you copy paste the code, then when you run, then you should get this graph, okay. So this graph is your action potential V. Okay, question A1. So question A2 ask you to plot the ion current, the sodium current, potassium current, and the leak current IL in a single plot. So let's look at how to solve for to calculate to plot I sodium, I potassium, and I leak. Okay. Okay, so when you solve the ODE, when you solve the ODE here, what you are actually solving is you solve for this four equation here, meaning that you are calculating for voltage, for variable N, variable M, and variable H. So now you already obtain your value V, N, M, and H. But if you look at the currents here, the three currents here, you need to combine, you need to rewrite back, because now you have the currents here have the variable M, H, V, N, okay? but now you only have the value V, N, M, and H separately. So from your solution here, you don't have the currents. So you need to recalculate the currents before you can plot. So what you need to do first is to define to redefine your value V, N, M, and H. So Y here, the big Y here, when you solve, for the Y, the big Y here has 4 column, okay? Has 4 column, meaning that the first column is V, second column is N, the third column is M, and the fourth column is H. So here in the plot, you are plotting for the first column, meaning that you are plotting for the voltage only. So now you need to recalculate the other values here. But first, it is better if you can separate the Y into its variable given in the question. For example, like V equals Y1. Okay, so this is voltage. Okay, and the second one is N. N equals Y, second column, and so on. Okay, M is Y, the third column, and H is Y, the fourth column. After you separate them, then you can rewrite the currents here. For example, like I sodium equals G underscore Na times M cube times H times E minus V sodium. Okay, so continue writing for the other currents. Okay, so when you write the currents, you have the other parameters like G sodium, G potassium, Gl, V sodium, V potassium, and Vl. So if you look at your function here, you don't have the variable, the parameters, but the parameters are located in the second function here. So what you need to do is you copy the currents or the parameters and just put it on the first function. And after that, you can plot the current. Okay. Then let's try. Okay, ada error. Kita tengok apa error. Okay, dia nak letak dot. So letak dot. So kita letak dot. So these are the current. Okay, the currents. Sodium is green, potassium is blue, and ionic is the red one. So here, from here, you can add, you can improve the code by adding the labels. Okay. Ada orang nak tanya? Ada orang nak tanya?
Tak, saya saja curious apa benda yang tangan ni. Punya angkat tangan punya. Sorry sir.
Okay, fine. Okay, so this is how you calculate something that is not solved from the ODE. Okay, so the ODE only solve for V, N, M, and H, but for the currents you need to recalculate. Okay, recalculate. So to recalculate, you just add a few lines. Okay, meski 3 line je, yang ni boleh delete, tak payah, tapi kita buatlah untuk bagi clear apa benda yang berlaku. So that's question A basically. So for question B, assume that a drug tetrodotoxin is now applied to the nerve which completely blocks all sodium current. Using the same initial value in A, plot V and the current. So drug ni basically dia block sodium current. So what you need to do is you need to create another M file. Create another M file and then copy, paste there. And then you need to adjust the code in HH prime here supaya menggambarkan yang sodium current sekarang dah tak ada. Sodium current dah tak ada, kena buat macam ni. So ni sodium current. So kena adjust kat sini, okay? Adjust here to represent no more sodium current. No more sodium current, jadikan dia macam tu, kenalah fikir sikit. Okay, lepas tu plot, dia akan keluar balik plot yang macam question A tadi. Okay, tu clue untuk question 2A. So nanti hantar malam ni lah, okay? Okay, so nanti study, okay? Alright, so now
Ada yang hantar malam ni juga ke?
Saya tak dengar.
Yang 2B yang hantar malam ni juga
Ya.
Okay.
Yes. Supaya kita boleh discuss esok, okay? Tak pun, kalau korang nak hantar hujung minggu, kita discuss hari Khamis. Test buat hari Jumaat. Mana satu nak? So test dijadualkan hari Khamis minggu depan. Mana satu korang nak? Test hari Khamis ke hari Jumaat? Sama je, waktu yang sama, pukul 8. Kalau nak hari Khamis, kalau nak hari Jumaat, kita untuk assignment 2B hantar hujung minggu.
Selesai hari Jumaat sebab Jumaat barokah sikit, hari yang barokah kan.
Ayo buat. Barokah sangat.
Alhamdulillah kau nice.
Tiba-tiba kan barokah. Kelakar. Tak okey je. Khamis ada PPC exam. Betul juga. Khamis tu selalu mesti lepas kelas saya mesti ada PPC. Tension tu sibuk je. Okey lah, kita buat hari Jumaat. Tapi assignment semua hantar hujung minggu lah, okay? Before Monday. Ataupun before Monday, okay? Before Monday midnight, Ahad midnight lah. Sunday midnight, okay?
Okay sir.
So tomorrow kita akan go into console and then ada assignment baru pula.
Oh.
Di present.
Laju sir.
Okay, kita try buat exercise mana tadi. Okay, exercise ni diambil dari past year. Okay, so exercise ni lebih kurang macam soalan assignment 2B, okay, assignment 2B. So how to do this kind of question? Okay, so in this question, a model to describe a population signaling is given as ada 3 ODE. So kalau nampak soalan ni janganlah terkejut, apa benda lah signaling ni, terlantak ada, yang penting korang tulis kod, okay, tulis je kod. So here, N, E and A represent the cell density, the killer molecule and signaling molecule respectively. The parameters are as follows: the N 0.004, the E equals 2, the A equals 4.8 times 10 power minus 7, K equals 0.97, and N equals 1.24 times 10 to the power of 9, and the A 0.639. And then dia kata the parameter DE controls the elimination of killer molecule. Tiba. Okay, question A. Simulate the model using initial conditions equals 1 for all variables. So initial condition dia 1 untuk semua. And for time range 0 from for time t from 0 until 100, KE equals 2. Okay, so firstly, sebelum kita solve this equation problem, simulate the model, so you need to write the function ODE first, okay? Okay, tulis yang function dy dt dulu. And then from there, determine how many ODE that you have. So here you have 3 ODEs. So dy dt equals 0, 3, 1. Betul tak? So yang ni kita tulis for ni Pak Wajib tulis rasanya, tapi tulis je ni sebagai precaution ni. And then after that you write all the parameters given. So the first parameter dn equals 0.004, de equals 2, PA equals 4.8 times 10 power 7, A equals 0.97, and M equals 1.24 times 10 power of 9. EA equals 0.639, and then KE equals 2. After you have written all the parameters, then you can write the ODE. So dekat sini kita kata ODE itu dalam bentuk dy dt, okay? Meaning that dy dt1 equals dn dt, dy dt second or 2 equals de dt, and dy dt 3 is dA dt, okay? So sebab ada tiga ODE, so dy dt 1 ialah yang pertama, dy dt kedua is the second ODE, and dy dt 3 is the third ODE. So in the ODE code, you just rewrite the equation given here. So dy dt 1 equals A times, okay, so sebelum tu dari 1, so Kat sini kita ada dy dt. So kita juga ada y. So y1 equals n, y2 equals e, and y3 equals a. Okay. So dy dt represent the dy dt here, but macam n, a semua ni represented by y1, y2 and y3. Okay. Okay, so when you write the equation for the ODE, so you need to make sure the symbol given here. So here, k times n. So n is y1 times 1 minus n. So n again y1 divided by nm minus dn times e. So e is y number 2 times n y1. Okay, cara lain yang boleh korang buat ialah maybe you can define first the variable. Okay, for example, like n equals y1, e equals y2, a equals y3. Kalau kita dah define kat sini boleh terus tukar je n e times n. Okay. So tak adalah confuse sangat. Okay, so the next one is dy dt2 equals ke times a minus de times e. And then lastly, dy dt3 equals dA times n minus dA times a. Okay, lengkap dah untuk function ODE, semua ada. Okay, three equations, you have three equations, you have parameters. Okay, and then you need to write the calling function. Okay, so function ey. So first thing you need to have in this function is your time span. So time span equals starting from 0 until 100. And then initial condition. So it says initial condition all equals 1. So ada tiga ODE, so ada tiga initial condition. Okay, so semua sama dengan 1. And then lastly, you can write the ODE 15 as. Okay. So call the function ODE, put time span, and put initial condition. Okay, ada kod ni, dapat dah soalan pertama, soalan A. Okay, after that, question B says plot N, E, and A against time in one single plot using different colors. Okay, kita plot dulu. Okay, sebelum plot kita asingkan Y dulu. Okay, so N equals Y first column, E equals Y the second column, And lastly, A equals Y, the third column. And plot time in E, and then A. And then kita try run. Okay, so dapatlah some graph, okay. So tak nak confuse, kita letak legend. Okay, so in question B, it asks for determine the steady state value of N and E. So steady state value maksudnya value yang dia dah steady, okay, yang dah straight line. So N value dia roughly 0.99. So E color merah roughly 0. So maybe you can put in comment steady state value for N is about 0.99 and E is 0. Dapat dah maka ini je. Okay, after that question C. So question C, an experiment is carried out that stops the killer molecule from being eliminated. Okay, write a new code to simulate the case using the same initial condition and time range, and then repeat process in B. Comment on the steady state value N and E as compared to in B. Okay, so soalan ni basically dia nak suruh copy paste code tadi. And then kena adjust something dalam code supaya menggambarkan an experiment that stops the killer molecule from being eliminated. So dia nak kata yang killer molecule ni tak boleh dihapuskan. Macam dalam equation ni killer molecule tu boleh dihapuskan, tapi sekarang ni ada satu eksperimen dibuat supaya killer molecule ni tak boleh dihapuskan. So nak ubah parameter mana? So dekat sini dah bagi clue dah. The parameter DE controls the elimination of killer molecules. So kalau killer molecule ni tak boleh dihapuskan, meaning that we assume DE equals 0, okay. So adjust je dalam code ni, letak DE equals 0. So DE equals 0 to represent killer molecule cannot be eliminated. Dan tukar semua nama. And then save and rerun. Okay, so you get a different graph. And then question says repeat the process. So plot graph and then determine the steady state value N and E. So steady state value. So for N it's about dia tak sampai steady state, so kita assume dia around 0.3. 0.3 and B and E is, so E is about 4, sorry, 4.1. Okay. And then after that, comment on the steady state value of N and E as compared to in B. Comment, disuruh comment soalan B tadi dengan soalan C. So soalan B tadi kata steady state dia N 0.99, E 0. Tapi sekarang N jadi 0.3, E jadi 4. So comment je lah apa-apa. Comment. And the steady state value use. Apabila 400% in komen lah macam ni dapatlah full mark gitu. Selesai soalan, berapa minit? 20 minit je. So test korang nanti setengah jam je lah. Okay, so for question assignment question 2B, the question is something similar, okay? So the question is something similar. So for question A, you need to write the code for ODE and the calling function. And then question B, you need to plot in one plot, different colors. And then here, you need to determine the time when I reaches maximum. So to determine something here, you just look at the graph you plot, okay? So determine roughly, okay? Tak perlu measure ataupun buat code, okay? Just roughly determine, okay? And then question C, in a different population, the recovered group may not become susceptible to COVID-19 again. Ni kena tengok balik statement ni, nak tukar apa. So here, dia dah bagi clue dekat delta here, represent the ratio of recovered people become susceptible again. So tukar sikit code, and then repeat process in B and then comment on the difference between the two results, okay? So question dalam test lebih kurang macam ni lah, tapi disebabkan format test yang baru, format exam UMP yang baru, dia suruh separatekan soalan macam ni, plot satu soalan, then determine another soalan, and then macam question C ni maybe ada 3 soalan lah, kena separate kan. So nanti macam banyak lah, okay. Sebenarnya satu soalan je. So for next week, nantilah kita discuss test pukul berapa. So test pukul 8 macam tu, sejam setengah, sejam 40 minit macam tu. Okay, so that's it for today's class. Any question before we end the lecture?
Sir, yang ni hantar weekend ni answer kan?
Nak hantar hari ni pun boleh.
Tak weekend lah, weekend.
Sir, nak tanya,
Yeah.
bila masa kena guna ODE 4550S file blah.
Oh, selalunya kita guna ODE 15S. Sebenarnya ODE 15S tu yang paling macam nak cakap paling stabil lah. Macam ODE 45, ODE 23 semua tu for cases yang maybe equation dia complicated ke, ataupun bila you selalunya bila try bila try run, maybe dia lambat nak solve ke, stiff problem, kita panggil stiff problems ni maksudnya it takes time to solve the model, okay. Maybe ada convergence problem ke, So macam convergence semua tu rasanya korang belajar dalam numerical method. Okay, bila kira something, kita nak cari convergence dia. So bila kira, kita tak dapat nak converge. So kita boleh guna mana-mana ODE, tapi yang paling disarankan ialah ODE 45 and ODE 15S. Okay. 45 ni yang paling cepat lah. Tapi kalau problem tu stiff, ODE 45 ni tak boleh guna dah. Dia tak boleh solve accurately. So orang selalunya guna 15S. So kita ada ODE yang lain. Yang lain-lain tu kita gunakan bila problem tu stiff, okay. Sama macam finite element problem juga. So dalam finite element, tak tahu korang belajar dulu dengan Dr. Jasri ke dengan Dr. Shah ke, bila guna software, bila buat complicated sikit, bila solve dia macam makan masa yang lama. Maybe bila makan masa yang lama tu mungkin sebab selalunya ada 4 sebab lah. Sebab pertama, geometri kita tu sangat complicated. So geometry is complicated. Second, maybe meshing problem. Meshing maybe terlalu besar ataupun terlalu kecil. Bila terlalu kecil dia makan masa yang lama dan makan banyak RAM. Bila terlalu besar dia jadi tak accurate, jadi error juga. Yang ketiga, I think your boundary condition. So boundary condition tu maybe like in ODE, it's your initial condition lah, maybe initial condition yang salah ataupun tak tepat. Lastly is your time stepping. Time stepping macam ni, kita guna time stepping ni, dia automatic time stepping. Sometimes kita kena guna time stepping yang kecil. So kita kena buat dia halus lah. Macam ni dia increase time dia by 0.001, but it will take so much time to solve. Tapi accurate lah. So your solution is nearly converge, but it will take some time to solve. Okay. So macam nanti maybe bila dah masuk console nanti, kita akan tengok lebih pada how to set in console. Maybe if we have problems related to convergence, maybe we will learn how to solve the convergent problems. Okay. Maybe during your project, bila buat project nanti, orang guna geometri yang pelik-pelik, so nak converge tu susah sikit. So kena ubah time step semua. Begitulah konsep dia, ubah meshing semua. Maybe FYP ke, tak tahulah. Beda kat dia ni. Tanya sikit je pun. Okay, any more question before we end our lecture?
No, sir.
Okay, so try install console and then kita buat console esok, okay?
Konsol ke?
Console yang hari tu dalam CD.
Right, sir.
Okay, so that's it for today. See you next week and tomorrow.
Next week. Stop.
Bye.
Alright. Thank you, Lukman.
Development.
Thank you, sir.
Bye.
Thank you, sir. Assalamualaikum.
Bye. Saya perform gitu. Thank you.
Saya nak tanya yang konsol tu kan.
Ya.
Saya ambil yang mana satu yang get into PC?
Oh, saya ambil yang saya bagi dia orang 5.3 rasanya. Tapi mana-mana should be okay kot.
Oh.
Should be okay, tapi maybe lain sikit je. Tapi lain sikit tu
Saya,
tak banyak sangat. Sorry?
saya ambil yang 4 year ago ke 2 year ago apa tu.
Oh, saya ambil yang 5.3. Kalau type dalam get into PC, console 5.3 then
5.3. Okay.
Ada WhatsApp. Okay, bye. Assalamualaikum.
Nice. Thank you sir.
Bye. The one on the left.